Okay, so 8.2 is volume of cones. The formula is 1/3 pi r squared h. So the only difference is the 1/3. The cylinder is pi r squared h, right? So the only difference is 1/3 of it. Okay? This little s right here, we're not going to work on today. Thanks, girls. Thanks. But later on, you'll see things where it says S and it'll say slant height. You have to use Pythagorean theorem. Most of the time, they're triples. You remember those, like 3, 4, 5? Most of the time, they're triples, so you don't really have to do a lot of extra work. Right, Alyssa? Right, Emily? Okay, so here's an example. We have a height of 6, a radius of 3 inches, and I want you guys to find the volume of this cone. Okay? So all we have to do is plug these numbers into that formula. So height of 6, radius of 3. Okay? So remember, the only difference is 1/3. Now, the easiest way to plug it into your calculator is to square your radius. So that's 3 squared is 9. 9 times 6 times pi. And then when you get all that, divide it by 3. Don't try to multiply by 1/3. That'll be annoying. So do 9 for the 3 squared times 6 times pi equals, and then hit divide by 3. And what you should get if you do that is 56.5. Okay? So 56.5 inches cubed.
Wait, what do we do with the 1/3? How do we
divide by 3?
Calculator?
Just get this, multiply it out, and then divide by 3.
Oh.
Okay, any questions on that? If you have your calculator or you're using your phone calculator, just check that you're getting it right. So you want to do all the multiplying and then divide by 3.
Is it 3 times 3 or 3 times 3?
3 times 3.
Okay.
3 squared is 3 times 3, right? So 9.
That's what I thought, but
Okay? All right, let's try working one of these with a solid. Okay? Composite solid. That means it's like 2 shapes in one. So I'll let you guys kind of draw the picture and then we'll figure it out. So we have a cylinder attached to a cone, right? So how you draw it is you draw an oval first, and then 2 straight lines, and then another oval, and then just connect the bottom like a cone. This is a 5. You guys thought you were in math class, but you're in art class, huh?
I have a C in art.
Oh no. Okay, so what we have to do is find the volume of the cylinder, add that to the volume of the cone. Okay, pretty straightforward. So volume of a cylinder, we already learned it's pi r squared h. So that's step 1. So pi r squared h, so that's pi, and r is 4, right? Because the whole thing is 8. Did you guys see that? So half is 4. Okay? Times 4, which is the height of the cylinder, and that works out to 201.1. Then we have to find the volume of the cone. So volume of a cone is 1/3 times pi, still radius squared, and our height for the cone is 5 feet. So radius didn't change, right? So that works out to 83.8. And then you add them together, and you should get 284.9. Can anyone think of like a real world example when you would use something like this? Anyone? Yeah, Imani? Houses. Okay. So if you want to try to find the volume, maybe something else that maybe not a house, but like something that we fill up entirely with something. Yeah.
Like a box.
A box, like if you wanted to ship something, maybe. Yeah.
Fish tank.
A fish tank. How much water does it hold? That's a good one. Yeah.
A garden dome.
Oh, because of that, the hat. Yeah. But something that like we fill it up, and there's a lot of these in the valley. When you just drive around, you see them all the time in the valley, like on 99. Yeah.
A water jug.
A water jug or like a water tank. Any other thing that you see that holds things? Yeah. I'm thinking it looks like this, but flipped over.
Water bottle.
Well, that was kind of what Allie said. What is it called? Someone said it. It starts with an S. You ever see them? They hold grain. Some of them hold milk. What? A silo. Good. So silos are basically this. It's a cylinder, right? And then the top of it's like that. And so if you want to know how much your silo is going to hold, right, then you would use the math to figure out, oh, okay, well, if I can measure the diameter and the height, then I can figure out how much grain I can put in my silo, right? So they actually do use that. That's normal math to use. It's more practical than probably the algebra that you guys have been doing. There's a bunch of these over by the airport. Have you guys seen them? They don't have the cone on the top, though. Have you seen them?
Oh,
There's like tons of them. They're by the airport, kind of, but if you're on 180 going to Kings Canyon, you see them.
What?
No, they're past that. You haven't seen them? They actually hold wine. Yeah. They're cylinders, but they're like huge, like silos. Do you guys ever like go?
I went to the airport on Sunday.
Okay, if you're on the east side of the airport, east side of Clovis Avenue. Yeah, but when you fly in, sometimes you can see them. Certain times of the year when they were harvesting the grapes and then fermenting them, you could smell it. It stinks really bad. It's from that place. Yeah. Yeah, it's like a barrel. Oh, a barrel's another one, yeah. I'm talking about the silos that look like that.
10 feet tall.
Yeah. This is huge. They're like 50 feet tall. Okay, any questions on trying to figure out how do we put these together? We can do it. Break it down. Don't try to do it all at once. Like, that's why I did steps, right? Okay, so that would be cones. We're going to do some practice on that in a little bit, but let's go to the spheres. Volume of a sphere. This is the last section of chapter 8 that I'll teach you. This formula is a little bit different. We don't have a height in a sphere, so we're getting rid of the height, but we still have the radius. Can anyone think of something like that we would fill up a sphere with? A sphere shape, like that we want to measure? Yeah? A beach ball, so you could measure the air inside of there? Yeah.
A water balloon.
A water balloon, you can measure the water. What else? Bryce. Okay. Oh, Jordan had a good one, those little chapstick things.
Oh, yeah.
How much chapstick goes in there? What else, Paige?
Fishbowl.
A fish bowl, yeah. An orange.
Stuff that goes into
We could measure that.
like basketball and
Air.
air. Yes.
Yeah. So you could use that formula to measure.
Air is so weird.
Okay. So guys. 4/3 is the standard. Okay, that's going to go in front. 4/3. Then the pi is in all three of these formulas. The r is in all three, but now we're cubing it. So it's 4/3 pi r cubed. So when you put this one in your calculator, it's easiest to multiply it by 4, and then once you get that, divide everything by 3. It's just easier that way, okay? I'll show you that in a minute. So here's an example. We have a sphere with a radius of 6 millimeters. So this would be pretty small, maybe like a gumball or something, right? And then we have the formula. All we have to do on these is plug in the 6. It's pretty easy. How do you do 6 cubed in your calculator? There is a button where you can raise it to a power, but just do 6 times 6 times 6. So in your calculators, you want to do 6 times 6 times 6, which should be 216. Then times pi, which is like 678 something. Then times 4, hit the equal sign. Then divide all of that by 3. So hit divided by 3.
904.
Yep. You guys want, those of you who have your calculator out, you want me to run through it again?
Wait, yeah, wait.
Okay. So in your calculator, go 6 times 6 times 6, and then hit equals. Do you get 216? Then hit times pi equals. Should get like 678.5. Then hit times 4 and equals 2714.3. Then divide by 3 equals. Yes, Jared?
Can't you do that little arch thing?
You can. Are you talking about the parenthesis?
No, this thing. For the distance.
Everyone's is different on theirs, but yes, you could. Yours has a power to a power on it. Mine does too. Mine's y to the x. Some people on the iPhone, it doesn't say y to the x. Does it? I forget what it says, but it doesn't say y to the x. It says something else. Yeah.
So like when you do 3.14, you get like a smaller number.
Yes.
If you did that on the test, would it still be right?
If you were writing it in, it'd be right, but if it's multiple choice, it's going to mess you up. And half the test is multiple choice. So you really need to get a calculator. I think I told you guys on Tuesday, right?
Yeah.
Yeah. Bring a calculator. Get one this weekend. I'll send a remind out. All right, now we have this other thing, part of a sphere, that's called a hemisphere. It's half a sphere. Did you know this? Did you know a hemisphere is half a sphere? You've heard hemisphere because you study science and you hear like the Earth's hemisphere and okay. So it's just half. So do you think the formula is pretty much the same? Yes, but now we just have to divide it by 2. So whatever answer you get, you're going to divide by 2, right? So here's the example of that one. So you kind of like do all the work and then at the very end hit divide by 2 equals. So we're going to do, in our calculators, 5 times 5 times 5 equals 125 times pi equals 392 times 4 equals 1570. Divide by 3 equals 523.5. And then divide that by 2. So you should get 261.79, so 8
Wait, do you divide the 50 by pi or times it?
times.
Oh.
Yeah, of course. So the calculator way is 5 times 5 times 5 equals 125, right? Then you multiply that by pi times pi equals, and then you multiply that by 4 times 4 equals. Then you divide by 3. Hit equals each time just so you know you don't mess up. And then divide by 2 for the 1/2. Oh, thanks. Could you divide by 6 instead of dividing by 3 and 2? Yeah. Would that confuse some of you? Probably. But you can do that. If you see the shortcuts, use them. That's fine with me. So what we're going to do is we're going to do some practice on the cones, some practice on the spheres, and then your homework is only 10 problems. It looks like more, but I promise it's only 10. I just chose different problems. Okay, so I'm trying to make this so you can see the whole thing at one time. Okay, so practice for the cone we'll do first, and then we'll go over to sphere. So we're going to start on page 600.